Today I'm going to talk about the motion, which is projectile motion, and the complete play. So let's move projectile motion. Projectile motion. What does it mean by projectile? Whenever we are dealing with a case like projectile motion, first of all, let me discuss the physical independence of the motion. We know that there are two axes. We all are aware that there are two axes, x-axis and y-axis. And there's one thing that we need to remember while writing or understanding the phenomena of the projectile motion, that they both are independent to each other. Neither the y-axis dependent upon the x-axis or not the x-axis dependent upon the y-axis. They both are independent to each other, and that's why it is known as physical independence of motion. Physical independence of the let me check it right. Yes, it's called as physical independence of motion, right? So let's move at what is projectile motion. Let me just read it. I don't think so. Got it right. Right. Yeah, let's move. What is projectile motion? When a body is thrown in a earth gravity, when a body is thrown in earth gravitational field, gravitational field, this is known as projectile motion. This is known as projectile motion. And there is only one force that is acting upon a body. This is only gravitational force. The motion of a rocket, cracker, driven by. Let me discuss it, right? So let's go. We know that. Wait. This is x-axis. For example, the bone. This is a ball. It's placed here. The one other ball is placed here. And when the ball is projected, it's something like this. This is basically an initial velocity, ux acting in a horizontal direction. This is basically ui acting vertically, and this is u is the initial velocity. Okay, so I will discuss that in detail as well. For example, this ball is then here, then it reaches here, then it reaches here, then it reaches, ultimately it falls down, right? So the main point to tell here is that the only force of gravity is acting here, and this is minus g. Now why it is minus g? Let me discuss it here as well. This is minus g. This is minus g, and so as for it, and see, yeah. Okay, so if I have projected a ball and there's something external force rather than gravitational force acting upon the ball, so there is non-projectile motion. It isn't projectile motion. For the projectile motion, for it should be it should be as well gravitational or the gravitational field, right? What I was telling here is that, yeah, why we have considered minus g. So let me read it. I don't think this was it. Wait. Oh my god, I have duplicated. Oops. Delete. Okay. Wait. It's deleted. Yes, we know that there are two axes. We are only considering 2D motion here, not 3D. So this is something like this. This is y-axis, and this is x-axis. Okay, there are two axes acting here, y-axis and the x-axis. Okay, so this is a positive, this is positive, but we consider gravitational field in downward direction, which means this is minus y, and so as this is minus x. So that's why we do consider the gravitational field acting downward is minus g. Okay, let's proceed further. Let me read it. let's go. Yeah, it's still eating. Okay, for example, I have a body. Let me give you an example for so that you can understand. This is a surface. Now I have projected a ball in an upward direction in a 1D motion. If the only y-axis or the vy velocity, which means the velocity of the y direction is active, it only moves in a vertical direction like this. But if I just give some horizontal velocity to this ball, which is ux, it also moves in a horizontal direction, and it is no more a one-dimensional motion, which means now it's a projectile motion. It's something called like this. And so as for the body ball, for example, this ball is being projected from this direction, and so as for this ball as well. So it's projected something like this. First of all, it has only vertical velocity, which means it was moving in a vertical direction. But if I give some horizontal velocity, something like this, and this is the initial velocity, it moves something like this, and then this, and this, and so on. So this is projectile motion. Then one thing that you need to keep in mind is only one force acting here, this Earth gravitational field. And yes, we have to consider here there is no air resistance. No air resistance. Keep this thing in your mind that there is no air resistance acting upon it. So the acceleration of particle at every direction, as I said, is minus g, minus g, minus g, minus g, right? Okay. So one thing that I need to tell you guys here is as well. So let me raise it. I think so it's no more needed to explain, right? Okay. Let's go. This is two motion. Now I'm not making the complete projectile motion, taking a part of it. For example, this is two axis. This is ux, which is equals to u cos theta, which means horizontal direction. Okay, u cos theta. Okay, wait, it's taking time. Ui is equals to u sine theta. I don't know where it is. Theta. I can use O for theta, right? So here, this is the initial velocity or the u acting upon here. This is u acting upon this body, initial velocity. So here the uy sine theta, the factor varies, but the u cos theta remains same. Because uy sine theta, the force of gravity is acting upon minus g. The body is attracted in the downward direction. While the ux in the ux theta, we know that the gravitational field does not act in the horizontal direction. So here the acceleration is 0. And if acceleration is 0, which means the velocity is constant, velocity is constant. Here the velocity is constant and acceleration is 0. So horizontal component of velocity will remain same in y direction. In y direction, velocity will be 0 at high. Okay, let me discuss at highest point as well. Okay, so let me just make the diagram of the projectile motion once, so I can conclude all the important points in just one diagram, right? So let's go. Let me make it. I can take a wait. Let's take Milik. I don't think that's it. Okay. Oh, this is a path. This is a ball. Please, here the initial velocity is 0, and so as for the final velocity. Okay, now ball is projected something like this. It follows the which path? It follows the projectile path, right? So this is a ball, this is a ball, and so as I don't need to make a ball here. This is ux velocity, this is uy velocity. Uy velocity, this is ux, this is uy, this is initial velocity u, and this ball then goes here, then it goes here, then it goes here, and so on, all the same path, right? So when here the velocity of body is variable, which means acceleration is minus g. In the vertical direction, this minus g. While in the horizontal direction, the acceleration of body is 0 and it's acting with constant velocity. So in the projectile motion, the vertical, let me write this point here. Vertical Okay. Oh, right. Right. Okay. So in the vertical direction, minus g is active. Right. While in the horizontal direction, the acceleration is zero, and we have constant horizontal direction. Velocity is equals to constant, and acceleration is zero. Okay. So it's done. Now I would like to discuss about one more point here, which is related to projectile motion as well. Okay, I don't need to make a diagram yet again and again and again and again. So I can explain it with the help of this diagram as well. So let's bring this diagram here. Let me increase the size. Okay, let's go. So I can take a dark color. Okay, this yellow. The body is projected from this direction. This is a direction of projection. This is a point of impact where the body comes back. This body is projected, moves here. First of all, what happens? This is a initial velocity, which means the initial velocity of body in this direction is maximum. Maximum. Then it reaches here. Then it reaches here. One more ball. One more ball. One more. And when it reaches here, the velocity, which means the velocity of body becomes zero. And then again it increases, and here again the velocity of a body is maximum. But at this point, when the vertical direction velocity is equal to zero, which, do you think that the body will fall down? No. Here the Vy component, we can say yes, I admire that it's zero, but here the Vx component is still acting, Ux component, I'm sorry, and that is u cos theta, which has constant velocity, due to which body does not fall, and after a while it increases its velocity again, constant. That's why the body does not fall here. When velocity is zero, body does not fall, as I said, because the u cos theta is still acting, which displays body in the horizontal direction. Right. So from all the point, we can conclude that they are basically two component. Okay. Let me begin. Wait. Get here. Let's go. Let's do it. Two component, ux, uy. So each component is, each axis is independent. Uy axis is independent, ux is independent, right? For finding the vf and for finding the distance. For distance we can add ux, for vf we can use uy. So each axis is here is independent to each other and does not depend upon each other. We can divide this to um, directions, which is ux and ui independently, and yes, this path is known as trajectile path. I forgot to tell it, so we can go to this point here. This is projectile trajectory path. Trajectory path. This is a trajectory path. So yeah, this is a basic concept about projectile motion.